In this video, we will solve a system of linear equations using the substitution method. Now you'll notice that neither of these equations have a variable isolated. So before we can substitute an expression, we have to do that isolation first. So you can take a look at both of these, and something that I try to do is see if there's maybe a quicker or an easier way to isolate a variable. What I mean by that is you look for single variables. So I look for something like this y, because it doesn't have a number attached to it, which would require me to divide. This x would also work, it just has a negative sign, which would be fine. Either of those would work. To me, the y looks like the easiest, because as soon as I take care of this, it's just y equals. These would be more complicated. So either way that you go about it, you just need to get one variable isolated. So this now becomes y equals -5 plus x. So these are the exact same equation, just written in two different ways. Now we added x to both sides just so that you're following. Now is where we can do the substitution, because we know that y is this expression. So we can actually take this expression and plug it in for y right here. Let's do that. 2x minus 5 times, now instead of y, I'm going to put that expression in, -5 plus x is equal to 1. Now I have only x's in this equation, which is great, and now I can solve for x. I'm going to have to distribute this -5, so I get 2x. -5 times -5 is positive 25. -5 times x is minus 5x is equal to 1. So we can do some combining like terms, and we get 25 minus 3x equals 1. And then we finish solving for x, so we're almost there. Let's move all of the constants together and then keep our variables on one side. So we get -3x is equal to -24. Lastly, we divide by -3 on both sides, and we get that x is equal to positive 8. Now again, we have half of our solution. We still need the y value. So you can get the y value in a few different ways. All of them require you to do the same action, which is to take 8 and plug it in for x there, there, or in this new equation that we made, there. It is highly recommended that you use one of the original equations, because if you messed up somewhere along the way, you at least know that you are plugging 8 back into one of the untouched equations. Okay, so I will take this first equation and plug in 8. So I get negative times 8 plus y is equal to -5. So I get -8 plus 5 equal to -5. Trying to figure out what y is, so I add 8 to both sides, and I get y equals 3. So there we have 8 and 3. Now written as a coordinate pair, we could write 8, 3 as our solution, and then of course we would check our answer by plugging in the x value 8 and the y value 3 into both equations.